7, 6. So we're going to add, subtract, multiply, and divide functions, and then we're going to practice manipulating composites of functions. Here are 4 basic definitions. One for addition, one for multiplication, one for subtraction, one for division. I'll pause to make sure everybody had a chance to copy it down. What's difficult for some people is the getting used to the symbolism. And it's really hard to get past this sometimes, but this does not mean f times x. It means f of x. It means the function in terms of x. Okay? And so when you see a number there in place of the x, like say f of 2, that means the function where the value of x is 2. Okay, and so we're going to find the value of that function when the value of x is 2. It does not mean f times 2. So be aware of that and be cautious of that. All right, first examples. If we know f of x is equal to 5x squared minus 4x, and we know g of x is equal to 5x plus 1, we want to find f of g of x. Well, remember, this symbolism means this is f of x plus g of x. And what did they tell me f of x was? 5x squared minus 4x. That's correct. And so I'm going to replace this with 5x squared minus 4x plus what they tell me g of x was. I'm sorry, I couldn't hear you. 5x plus 1. So I'm going to replace this with 5x plus 1. Then we're simply going to do what it says. Now, parentheses are not necessary here. I'm going to put them in for a moment anyway. This is all of f of x. This is all of g of x. We're adding them. But because we're adding them, the parentheses are not important. And so, are there any other x squared terms? And so I get 5x squared minus 4x plus 5x. What's that? I'm sorry, I can't hear you. X. So plus x.
Plus 1.
And then there's a plus 1 out here. No other constants in the expression, so we can't add anything to it. We just get 5x squared plus x plus 1. Okay? Any questions on that? Okay, subtraction. Again, this means f of x minus g of x.
So 5x squared minus 4x.
5x squared minus 4x
Minus 5x plus 1.
plus 1. Now, last time we said the parentheses are not important because we were adding. But this time we're subtracting. So are parentheses important here? Yes. That's correct, because we have to distribute our minus sign to every term in that second function, not just the first term. And so we get 5x squared minus 4 minus 5x
Is 4x.
minus 1. Oh, yeah, thanks. That was 5x squared minus 4x. I wrote it down wrong. Okay?
So we need 5x squared.
And so we get 5x squared
Minus 9x.
minus 4x minus 5x is minus
9x.
9x minus 1. Okay? So we add and subtract functions. The adding is the easy part. We don't have to worry about parentheses or anything else. We're just adding all the terms together. They're like terms. But when we're subtracting, we have to make sure that we distribute that minus sign into every term in that second function. Okay? All right. Moving on to multiplying and dividing. So if f of x is x squared minus 4 and g of x is x plus 2,
So
We want to find f of g of x. Well, from the definition, we know this is f of x times g of x.
So just the same thing.
And so it's going to be, are parentheses necessary here?
Yes,
Okay.
would you just FOIL it?
I would, yeah. In this case, I would simply FOIL these two. X squared times x is
X cubed.
x cubed. X squared times 2 is plus 2x. And then negative 4 times x is negative 4x.
Minus 2.
Sorry, did I say something wrong?
You said 2x.
Oh, 2x squared, yes.
Minus 8.
X squared times 2 is 2x squared, not just 2x, my bad. And then negative 4 times 2 is negative 8. And in this case, we don't have any like terms, do we? So we cannot simplify that. Okay? Then we go on to division. Applying the definition, we get f of x divide g of x.
And that's in G of X equal.
So that's x squared minus 4 over, was it x plus 2?
Yeah.
Okay. Now, how can I divide that?
Can't you not because your X is squared?
So you want to say x squared divide x is, okay? Divide negative 4 by 2. So you're basically saying that this
You have to take the
is equal to 1? Well, you are, because you're saying, actually 0, I guess. I get 1 and 1 and 1 and 1 and 1 minus 1 is 0. My bad. You're saying it was 0. Can I do that? No. I can't, can I? I don't know what is in our brain that tells us we can do things like that, but we have to work really hard to get that out. And you're not alone, believe me, you're not alone. I have this conversation almost daily with my classes, okay? You cannot take individual terms and cancel factors. You can only take them if they're in factored form. So if I want to cancel, I have to first factor that top. How does it factor?
X minus 2, x plus 2.
Yeah, it's the difference of two squares, isn't it? So that's x minus 2 and x plus 2. Now, do I have exactly the same factor in the top and bottom? Yeah, this x plus 2, that's a factor. And this x plus 2 is a factor, so they cancel, leaving me with x minus 2. Okay? X minus 2. Now, is there any other way I could have divided them? Let's say I'm not very good at factoring and I didn't notice, excuse me, I didn't notice that that was the difference of two squares, and I'm looking at it thinking, I can't factor it. What else can I do?
Use the quadratic equation to find the factors.
So you're saying I could use the top, find the zeros, and then write them as a factor?
Yeah,
That would work. So you want to use quadratic formula?
I guess.
Okay. Excuse me, I've got crud in my throat. I think there's an easier way to divide this. How did we learn how to divide polynomials? What was that S word we used? Synthetic division, right? So I could take the coefficients of that. What are they?
1 and 4.
1,
And negative 4.
0, and negative 4, right? Remember, x squared, x, and the constant, right? And there's no x term, so that meant the coefficient was 0. And then this is written as a factor. So what number goes out here?
2.
negative 2. Remember, if it's written as a factor, we take the opposite of that, the negative 2. And so if I drop this down, go negative 2,
That'd be a negative 2. You're adding.
and add that, it's negative 2, multiply is 4, add, I get 0. So there's my remainder is 0. My constant's minus 2, and my x is 1x. And so if I divide this, if I divide that out, I get
That.
x minus 2, which is the same as I got when I factored.
What would you say? Negative 1. Just.
Well, this method's easier for me because I notice it factored. But if I didn't notice it factored, then I'm going to want to use synthetic division. And by the way, if I get something here that's not 0, then it didn't reduce. Okay? Then I go back and there's nothing I could have done. I would just leave it as that fraction, x squared minus 4 over x plus 2. If you divide it out and it's not a 0, that means there's a remainder. That means it doesn't go into that number evenly. So it means that this term would not go into, or this expression here would not go into this expression evenly, and so that means I can't divide it. Okay? So you're looking for a remainder of 0. If it doesn't happen, then there's nothing you can do. All right? Any questions on that? So lots of opportunity to practice this stuff in the next 2 days. We're going to spend today and tomorrow going over this. And don't forget the checkpoint quiz. Okay?
What checkpoint?
It goes along with it. The composite of functions. This definition's in your book also. I'll pause, make sure everybody had a chance to copy it down. Composite of functions. Again, let's see where it was. Okay, so if you're at home watching this, make sure you get the rest of that. Okay, examples. F of x is equal to x minus 2 and g of x is equal to x squared. Find g of f of x. Well, the definition of that means that we're going to find g of f of x this way, which means we're going to take all of f of x and put it in place where x was in the g of x function. Okay? So g of x is x squared. So that means g of f of x is equal to x squared, but x is now f of x, which was x minus 2. Okay? Now, it's possible they left it this way, but it's not likely. It's likely they're going to go ahead and square that binomial, which gives me x squared. The middle term is x times negative 2 times 2. So that's going to be minus 4x. And then the last term is going to be negative 2 squared, which is plus 4. So g of f of x,
So how'd you get the negative 4?
remember when you square a binomial, you get 3 terms.
Okay.
The first one is
that
the first term squared. The middle one is the first times the second times 2.
Okay.
And the third one, the last square, is the last term squared. So the composite of g of f of x, g of f of x is equal to x squared minus 4x plus 4. Okay? What's the difference between example 1 and example 2?
This one, volume, and the other one, don't.
Log and goth. Yeah, Don't read that composite symbol as an O. That might create some problems.
Yeah.
The top one says g of f of x. What's the bottom one say? Or the second one, I should say.
Wow.
It's fog.
So we're not going to read it as an O. How do we read it?
F of G of X.
F of g of x. That's correct. And so that means, by definition, we're saying that this is f of g of x.
So we're just switching.
And so now the g of x goes in place of the x in the f function, right? So if f of x is equal to x minus 2, then I'm going to take all of g of x and put it in place of the x. What was g of x? X squared. And so that means I'm going to say that, sorry, I wrote it backwards. F of g of x is equal to x minus 2. And where the x was, I'm going to put all of g of x, which was x squared. And so f of g of x is equal to x squared minus 2. So where x was, I'm going to put all of g of x. Sometimes it's really simple, like this one. Sometimes it's really messy. But you have to put all of it in there. There might be 3 or 4 terms that might really be ugly. But that's the way it's got to be done.
What if we got bombed?
What's that?
So you're saying like on this next one, if we did fog, it'd be x squared minus 2, but then times it all by 3? Is that what you're saying?
I don't know, did I tell you that this meant f of g times 3?
No,
Or did I say that's not what it means? We have to be really careful not to think of it that way.
You plug 3 into the equation.
That's right. This means I'm putting 3 in where the x was in this composition. Okay? Now, we just found this composition to equal this, didn't we? Well, if you had to go through and do the work of that anyway, then you can think of it as reaping the benefits of it here. You can apply that. So this is going to equal x squared minus 2, where x is now 3. And so 9 minus 2 is 7. Okay? But I'm going to do it another way, because not always have you already determined what that is. Sometimes this is number 1 on the homework, and there's nothing else has been done yet, and you didn't know what f of g of x was. You just know what f of x and what g of x are. And so this means f of g of x. And so that means, to begin with, let me go back up and refresh your memory. G of x is equal to x squared. And so we have to do the g of x first. And so in this case, g of 3. Let me write it this way. We're going to find g of 3. Well, remember, g of x was x squared. So g of 3 is going to equal 3 squared, or 9. Okay? And we're taking this value of 9, and we're going to plug it in here and find f of 9 now. Because we found g of 3 to equal 9 right here, and so that's where the 9 goes. Remember, f of x was x minus 2. So f of 9 is going to equal 9 minus 2, or 7. Okay? So there's 2 steps to this, using this method right here. There's 2 steps. Okay? But again, if you did not already know this, If you didn't already know what that was, then you have to do these 2 steps, or you have to go back and find that other one first, and then find the answer. Okay, which is not going to be the easiest way to go if you haven't already done it. So Garrett, got this copy down? That'd be a no. Close enough. Good. All right. Any questions on this?
Is that all the notes we had?
That's all the notes we're going to talk about. Okay, today's homework, 3 to 51 by 3s, and then 80 through 84. I'll do all of those. There's 5 of them there. And then remember, tomorrow we're going to add the checkpoint quiz, number 2. You have today and tomorrow to work on those 2.
What was the second part?
It's 3 to 51 by 3s, and then 80 to 84 all. And checkpoint quiz tomorrow. I think I forgot to check your quiz, so I'll try to get that done later in the conference period. Alright, so you have 15 minutes to get started today, and you have all class time tomorrow to work on that.